Hey guys, so I just want to work through page 73 and 74 for tonight's assignment, so feel free to follow along. Also, I posted the answer key if you need additional help. Last thing, you can always email me with questions, and then if we have questions, we'll go over it tomorrow in class. So here's page 73. We're going to move into comparing functions. So far, last section, we talked about functions. For every output, there is one specific input. Think about going to the barbecue place. All right, so here's the example. The table and the graph show the relationship between the length of the sides of a square in feet and the perimeter of the square in the feet. So here is my input value, which is the side length, and my perimeter, which is my output. The relationship is a function, so we know this is a function because there is only one output for each input value. We can tell that by the graph and the table. So I could do my vertical line test and it passes. But more importantly, if you have a square where the side length of 4, your perimeter is going to be 4 plus 4 plus 4 plus 4, or 4 times 4, which is 16. If you have a square that is side length of 2, that will be 2 times 4, which will be 8. So that would be a function. So number 1, describe relationship between the input and the output value in the example. So it looks like there is a common ratio between the two of 4. So we can say that this is a function, but the perimeter is 4 times the side length. Okay. Can you represent the function in this example with an equation? If so, what equation can you write? Well, we know that to find the perimeter is equal to 4 times the side length. So perimeter is equal to 4 times S for side length. We can quickly check that by going, okay, if I have 4 times the side length of 1, my perimeter is going to be 4. That checks out. I can also do, let's say, 4 times, if I have a side length of 2, the perimeter is going to be 8. That checks out. So my equation works. 4 times the side length. In the example function, can one side length ever produce 2 different perimeters? So can one side length ever produce 2 different perimeters? In this example, because it is a square, it is no, because the square has equal lengths, and it can be represented by the perimeter is equal to 4 times the side length. So if, for example, if I put in 2 side length, I will always get 8 for a square. I cannot get something else. So that's why it is a function. So basically the question is, can you make this function a non-function? And you can if you change literally the parameters and the shape. But in this case, it's just a square. You cannot. Number 4, do the data in this table show a function? If you switch the input and the output value, would the data show a function? Explain. So right now, this is not a function. So, because it fails it multiple times. So, no, this is not a function because there are different outputs from the same input. So I can tell that when I input 2, I get 9, I input 2, I get 11. I input 3, I get 12, I input 3, and I get 14. That's not a function because I literally cannot go to 2 different restaurants at the same time. So I am going to switch colors though, because if switch, let's test it out real quick. So we're just going to reverse it. So it's going to be 6, 1, 9, 2, 11, 2, 12, 3, 14, 3. If switch, so this is my input and this is my output. If switch, it can be a function. Because now I don't have outputs with different inputs. I don't have the same output with different inputs. I don't have, sorry about that. I don't have different outputs from the same input. That's what I meant to say. I don't have different outputs from the same input. I can have this scenario. This checks off. That is totally a function, because think of it in terms of days of the week. If I input Thursday, I go to a barbecue place. I input Friday, I go to the same barbecue place. That is okay. That is a function. Number 5, substitute values into the equation to complete the table. Then state whether the equation represents a function and explain your reasoning. So right away, I'm just going to tell you guys that represents a function, because this is a linear function. If we were to graph this, this is a line. We talked about it in class where this is the initial value and there's my rate of change. So I'm just doing input and output. So let's input -2. So 5 times -2 plus 1. Wherever there is an input variable for x, I substitute in -2. So that would be 5 times -2 is -10 plus 1. That equals 9. -9. So when I input -2, I get -9. I do it again. 5 times I input -1 plus 1. So I input 5 times -1 is -5 plus 1. That equals -4. I input 0. Anything times 0 is 0 plus 1 is 1. And you kind of get the pattern here, because every time we go up 1, it looks like I am adding 5. So 1 plus 5 is 6, 6 plus 5 is 11. You can check that by continuing to input the values. But if you understand that this right there, the 5 next to the x, that is actually my rate of change. That's plus 5 each time I go up a step. That makes things a little easier. So whether, is this a function? Yes. Because for every output, there is one input. So it is a function. Number 6, teacher wrote these numbers on the board: -5, -3, -1, 1, 1, 2, 3, 4, 4, 6. The input-output diagram has been started using the teacher's numbers to form ordered pairs of a function. Part A, put the remaining numbers in the ovals to complete the diagram. So I am making a function, a mapping diagram. I'm mapping out functions. So let's just, and then B says if the input and output values reverse, would the diagram still represent a function? So I got -5, -1, so -5, -3, -1, 1. So then I get 1, 2, 3, 4, 4, 6. So right away, I can tell that this is a function, because for every output there is one specific input, so that is a function. B says if the values were reversed, so I'm just going to make a quick t-table and reverse this. So -3, -5, 1, -1, 2, 1, 4, 3, 6, 4. So if I were to reverse it, would it be a function? Well, let's check. -3 is -5 once, 1, -1. I have no repeated here. I have no repeated input values. So yeah, it will still be a function. So yes, because for every output, there is one input, and that makes it a function. All right, guys, I hope that helps. I'll see you guys in class.